Hello everyone. We are group number 2. This is our final project demonstration. Our project is IoT based aquaculture monitoring system. Uh, the group members of our project group are 1906-139, 1906-141, 1906-144, and 1806-054. This is the introduction for our project. The key features of our project are sensor integration. We have used different type of sensor like the temperature sensor, pH sensor, and the water level sensor. Then we have used ESP32 for data transmission. We also used Arduino Uno in order to control our system, and then using ESP32 we have integrated real-time monitoring, and we also integrated parameter controlling. These are the components that we have used in our project. We have used waterproof temperature sensor. Then we have used water level sensor, pH sensor to collect the pH level data. Then servo motors to implement the feeding system. Arduino Uno to control the system, and ESP32 to upload the data to the website and the app that we have used. These are the circuit diagrams that we have implemented in our project. Here in the first picture, we can see the circuit diagram for the water level, the waterproof temperature sensor, and next slide, Aja. And these are the circuit diagram for pH sensor and the water level sensor. Now, 139 will present the presentation.
Assalamu alaikum. My ID is 1906139, and I'm going to describe the design methods we have used for our project implementation. So, firstly, we have got three sensors: pH sensor, water level sensor, and temperature sensor. And we will get readings from this sensor, and these readings will be sent to IoT cloud using ESP32, and the user will get live update of the system. And we have implemented automatic feeding system that will keep track of time to feed the plants or fishes. So after regular interval, the container that will contain food or fertilizer, it will drop food or fertilizer to the uh, main pond using a servo motor. So this is the flow diagram of decision that depends on the sensor data. So the pH sensor will take the reading of pH level of the water at regular interval, and if the reading is less than 5.5, then there will be lime water addition to the pond water from a lime water reservoir. And if the reading is greater than 5.5, then there will be no addition of lime water to the main pond. uh, we will also have a water level sensor. Uh, we will get uh, water level reading from those sensor at regular interval, and if the sensor reading is less than half of the height of the reservoir, then the water will be added from a reservoir with the help of a pump to the pond water. And if we find that the water level height is higher than half of the height of the reservoir, then there won't be any addition of water. Similarly, we have got a temperature sensor that will keep track of temperature of the pond water, and at regular interval, the temperature sensor will take reading of the temperature, and if the reading is greater than 32 degrees Celsius, then water will be added from a cold water reservoir with the help of a pump to the pond water. And if we find that the temperature is within the optimum scale or less than 32 degrees Celsius, then there will be no addition of the water. So this is the implementation of our project, and in the left side we can see the hardware setup of our project, and uh, in the right side we can see that it's an app where we can see the temperature and pH level and water level height of our system. So the next slide will be presented by 1906141.
Hello everyone, I'm 1906141. So with the help of our project, we are monitoring and controlling the quality of water. As a result, the health of our fishes or aquaculture is maintained properly. So we can produce huge amount of our protein from this model, and it can play a great role meeting the demand of our demand. Next slide. So in this project, the limitations that we faced are we were continuously losing the signals while connecting the ESP32 with our Arduino Uno. And when we changed the location, we had to re-upload the code to ESP32. And it was very difficult to maintain the proper calibration of pH meter. Next slide. So these are the components that we used and the price of the components. Next slide. So to improve our model, our project, we can add salinity sensor, oxygen level sensor in our project. It will monitor and control the water level in a very good manner. For decision threshold, we can set some fine values, so the feature of the model or our project can be improved. Next slide. These are the references. Thank you.